Well, good morning, ladies and gentlemen. Well, yes, I'd just like to share a couple of views on what we do when we look at aircraft. And yes, it goes beyond crystal ball gazing, because we have to do a fair assessment of what happens within the aircraft development scheme, what happens in the airline business, how to have a flexible solution for the future, because we all know that we don't know what 2030 looks like. So we all know that we have to have a certain flexibility, and that makes it so interesting and so challenging to develop something. So let me go through a couple of points, and again, I see this like as a short presentation, but also what I would like to do is have a discussion, if you have some questions on why the hell did you do this, or great that you do this, whichever way, I'm willing to have a nice discussion on that. But, so what I was told by Niels, and you know that management is always controlled by somebody else. So to look a little bit at these items which I've listed there, and I'd like to touch on them, not like explicitly each item with a headline, but going through what we do when we look at these items. And again, I'm open for questions. So, but let me start with the recent news and what we did recently. Well, recently, some of you have seen this chart. We opted for an order of long-haul aircraft for Lufthansa passenger airline, and it's for Lufthansa passenger airline. It's aircraft for growth and replacement. And again, you already see in there the dance we're doing in terms of walking the line. Sorry when I'm standing in the way. We have 2013 till 2025. Well, we could go on, but 2025 does the job for the time being. We know we wanted to have alternative market scenarios. A growth of 1%, 3%, or 5%. Everybody agrees that the global aviation is roughly growing at around 5%. But the question is always, how much of those 5% average can we actually access as Lufthansa? Because like the typical Trans-Pacific market growth, whatever the number is not really within Lufthansa's market area. So we need to look at certain things. So we have said, well, let's have a basic scenario which says 3% growth. But at the same time, what happens if things go bad? Or what happens if things go good? Or much better? So we said, well, if things go bad, we want to go down to basically no growth. How do we do that with that order? And therefore, we looked at the order and said, well, with that amount of aircraft, and the amount of owned aircraft which I have, which would have a certain age, which have run out of depreciation at that time, we could retire a certain number of aircraft and therefore do more rollover than initially planned. Hence, suppress our growth rate. What happens if we need more growth? Well, as you know, we have taken some options, and if that is not sufficient, we still have the option to actually fly the existing aircraft longer. So we have like a completely breathing production, and now what I've listed here until 2025. And that is one of the things, like, we need to give a certain commitment because we need a baseline planning. Everybody needs that baseline planning, also the manufacturers, because I cannot come in 2020 and say, oh, by the way, guys, I need 10 aircraft this year. It's impossible because A, I don't get the seats from the vendors, B, Boeing or Airbus have not been waiting at that point in time to actually have some spare capacity. So we need to look a long time ahead, and that's the flexibility which we're building into our fleet planning. And that creates like interesting scenarios for us internally, but also when it comes to the discussions on the contracts with the manufacturers. What we have at the moment in terms of, and this is our group, until 2025, we have roughly, and at today's exchange rate, that is somewhere just below $50 billion on list prices. a commitment of roughly 300 aircraft total deliveries. That includes 2013. I could do it more precise, but I think as we are getting an aircraft within the system literally once a week or so, and we have things which leave the system, there's so much preparation that I'd rather keep onto a couple of dates per year, and hence we include the whole year. And it's 295 aircraft, and within the group we have roughly 700 aircraft in the fleet. Now, still sticking to that long haul, today you do not see Brussels on here, maybe just as an information. Brussels is not yet fully consolidated in Lufthansa, so we do not include Brussels in our charts. We do include Brussels in our thinking and negotiations, but we do not have them consolidated, hence they're not on those charts. You have a collection of aircraft in the long haul segment, size categories, and you go up. Well, obviously there have been a commitment to the A330-300. We streamlined the fleet regarding no more A330-200s. Then we look at the top part. We have the 747s, 777s now, and the A380. And the only open area is what we still have to decide a little bit is on Austrian, what will succeed the 767 and 777, which will happen in due course when we think it's in. We have sufficient option to do short-term decisions with both manufacturers. So the fleet gives us the normal thing when I look at the current fleet, and this is a blend of both aircraft types which we have ordered. It's a blended number, so one is a bit better, one is a bit worse, but they are still much better, both much better than what we have today. So we have about 25% fuel mile reduction, which translates into around 20% unit cost reduction, and we have gone significantly quieter compared to the aircraft we would be replacing. So that's maybe in a nutshell a little bit what we have done on the long haul. And now, what did we do for that decision? Not necessarily only for long haul, but how do we look at things? And maybe just to set the scene, yesterday we had pilots from Lufthansa. We had Joe Sutter from actually one of his engineering pieces, the 727 on here. So over the years, people have always said either form follows function, I could say, or function follows the form, or everything is marketing. And in the early days, it was always pilots who were somewhere at senior positions in airlines, and they had a big say on what aircraft would be bought. And it was mostly performance driven. Then engineering took over, in inverted commas. And you had engineering at its best. In the 80s, everybody looked like presentations came into style. You had marketing and everything like, oh, forget some of the other things. If I have a nice seat, I can sell anything. So it was everything about marketing. I think none of those three things actually would work in today's environment, or if they would be very short-lived. So today, we have economics, we have ecological awareness, and economics include everything. It's not only fuel burn or things. It's some airlines look at cash value added, capital expenditure, and you have all those elements which need to go in. So on one side, it has made it much more complex, the evaluation, but our market has become more complex. On the other side, for those who look at it, it becomes more interesting as well, because you have many more levers to play with. Also, historically, speed, size, and range were really the key drivers to develop aviation. And the key drivers on that, I think, in terms of range, and I have a lot of friends in some parts of the world, but I think in terms of range, on the long haul, we have sufficient range on all the aircraft. There's very few destinations which you cannot reach non-stop. So the range is there. The size with the A380 we have there. And the speed, we have tried to go beyond, and we have come back to subsonic speeds, because at the time being, for noise reasons and for efficiency reasons, we have not yet found solutions, and we in this case as the airframe manufacturers, airframe engine manufacturers, to get to an acceptable level of efficiency. If we move, for example, I just remind you of the Sonic Cruiser, which was nice, but it flew in a very unattractive, physically very unattractive area with a lot of resistance. So actually the benefit of the Sonic Cruiser was not there, which is why the Sonic Cruiser developed into the 7E7 and later into the 787. Big steps. How do we measure certain things? And we would measure what have been the real elements. We measure our aircraft as well, and we could say it's seat kilometers per hour because we're producing something. And seat kilometers per hour, over the years, when you do a rough average line, you see that the big jump really was a 747, but actually the A380 was not a big jump. Yes, we still have to fill it, but it wasn't a big jump in terms of technology and progress. The big jump in those days was a 747, because it was significantly bigger than anything else.
Is this doesn't reflect the efficiency, this is just the carrying?
That does the carrying power per hour, so it does take the speed into account. So it is the efficiency. Well, it is to a certain extent the efficiency as well. Not,
capability.
not the efficiency in terms of fuel burn, if you're relating to that. So at the moment we have, as a fleet management, we look at the fleets, and that comes back to what I said earlier. We have a very interesting life because we have to look at the markets. So we need to procure outstanding airplanes which have the best class over the life cycle. I know for short-term gain I can get something better in every specific year. But when we go into an aircraft, when an airline goes into an aircraft, that requires training on the technical side, training on the pilot side, infrastructure and everything. So we know we're there for quite a while. And hence, we need to look at the position over the life cycle of the aircraft. And the other thing we would like to do is to have a continuous look at our production tools, the aircraft, to understand the merits over a long period of time. Like what happens if, everybody does the what happens if fuel prices double. It's one of the very simple parameters because you can calculate that. So that goes into our business case when we bought some aircraft, like a couple of years ago. We doubled the fuel price just to see if our selection would actually come out second then. That the difference between the two aircraft, which we have been evaluating for that purchase, may shrink or increase is expected. But does actually suddenly become the preferred aircraft the second ranking or not, then we need to restart our thinking. And that's what we're doing when we say we run a couple of sensitivities. And we do that not only on fuel, we do that on noise or capacity. So it's a multi-dimensional matrix which we're using. Let me give you one example. And it's both a 150-seater. There was 25 years between those two. And we got 25% cash cost improvements. A lot came from the number of pilots. A big number came from the fuel burn reduction. Okay, that's one engine less as well. And then there was fees and maintenance, which were changed. If we look at today, we don't achieve these steps anymore. Because we have come to a flatter part of the curve, we're improving technologies, we're improving many elements, but we don't find these numbers anymore. So the efficiency has to come from the production cycle with the airframers, and has to come from the utilization and the more clever utilization thinking and use of the asset by the airlines. If you look over those years, you can also see that, for example, the average load factor, take IATA numbers or anything, has probably increased a double-digit percentage number. I mean, In those days, 65% or 70% load factor was considered extremely good. And I remember when I studied and I did airline operations, people said, oh, 65% is a good number if you achieve that. At 65% average load factor, I think all the airlines today would be dead. So that is something where we gain the efficiencies as well. The other thing is, let's just pick a 737. It started its life as a 100. Here's just the indication of the payload range of the 100. The latest sibling, the 800, has twice the range for twice the capacity. So there has been a huge development which happened, and you could do that for many aircraft which have been around.
What is the unit for payload?
Pardon?
What is the unit for payload?
That's tons. That is tons. So, hence, how do we actually work with this environment? We work with this environment as a fleet management team, and I have a couple of good teams looking at various elements of the equation to actually group all the information from all the manufacturers, airframe and engine, into my team. Then we also look at what do the airlines need